So that I'll do in red over here. And we're trying to prove that angle E is congruent to angle E. So what is like not made clear here? Did you end up having math today, by the way?
I didn't. No, no.
Okay. You first have to prove the triangles are congruent.
Yeah.
Okay. And there's only four ways to prove non-right triangles congruent. Side, 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 angle, side, angle, 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 side.
Yeah.
You've correctly identified that this third side is congruent. Why is that? What is the reason that RC is congruent to itself?
Because I said it was side, 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 so
That,
it would have to make three sides to be
well,
that.
okay. So that's number four. Number four is that triangle REC is congruent to triangle RAC by side, side, side.
Yeah.
Okay, but if you just look at it from one and two, you only have two sides. So how do you know that the third side is congruent?
Just like looking at it and like kind of
No,
uh, no, I don't.
no, you
That's the
can't
one.
do that. That's not allowed in this class. Yeah, I mean, you did like assumption, there's you know the rest. Can't assume. Now they
Yeah,
are congruent, but there has to be a reason why. Do you agree that
because
they are?
EC and AC and AR and ER are congruent.
No, it's nothing to do with that.
Oh, okay.
It's because it's shared. It's shared. Do you see that these are shared by both triangles?
Yeah,
All
yeah.
right. So shared, when you see something that's shared, that word's really important, or overlap, that is the reflexive property.
Okay,
That means it's congruent to itself. So you would write RC is congruent to CR.
okay.
Is that okay?
Yeah.
So now you have all three sides congruent. Now you can say the triangles are congruent. Once
Okay.
once you have the triangles congruent, you can use this thing called CPCTC. Does that sound familiar to you?
Um, kinda, yeah.
Okay, so
I
what
forgot
that
what it fully stands for, but I've seen it.
so what it stands for is corresponding parts of congruent triangles are congruent.
Okay.
Okay, and what that means is once you've proven the triangles are congruent, the corresponding sides, which you already have here, the corresponding angles, the angles, they're all congruent.
Okay.
Basically, it's all the things that you want to assume to be true, but you can't until you prove that they're congruent.
Yeah.
Okay. So that is where angle E congruent to angle A comes in.
Okay.
Thoughts on that?
Uh, no thoughts on that.
Matt, Remy's dad, what
Yeah.
does CPCTC stand for again?
Yeah. It's corresponding parts of congruent triangles are congruent.
Thank you.
And it typically refers to angles or sides. So the basic structure of these proofs is that when you're trying to prove something inside the triangles, like angles or sides congruent, you always prove that the triangles are first congruent.
Okay.
Then
Okay.
you do that as your last step.
Okay.
So like in proof number two, might as well just go in order here. In proof number two, you can see that they want you to show that two side lengths are congruent,
Yeah.
but you can't do that. You have to first prove that the triangles are congruent.
Yeah. Okay.
So your goal here in this proof, in this statement reason proof, is to prove the triangles congruent. Then you can use CPCTC to prove that the sides are congruent.
Yeah. Okay.
All right.
So would
So
I start just like marking like what's congruent, like CL is congruent to MB, and just
no,
like mark?
that's what you're trying to prove. You
Oh,
cannot mark that.
okay.
Yeah,
Okay.
that's like the destination.
Yeah. Okay.
You know what it looks like, but you know you're not there yet. No, you always start with the given. Always, always, always.
Okay.
So I is the midpoint of CM. I know it's maybe it seems like why would you do this? Like that's just the way these go. You just write the given first.
Okay. Got it.
Okay. Now we're only going to write the first given to start. So
Okay.
the other type of proofs that you will work on here, which is this one here, is where a statement leads to another statement. What does it mean? Yeah.
How do you know when there's not two givens?
Well, I'm just separating them there. I mean, they're usually by commas,
Okay. Okay.
periods. I guess maybe the previous one was a period. No, it was an and, a clause,
Okay. Got it.
conjunctions.
Yeah.
Yeah, different class. It's a good question. I mean, you can always ask your teacher. That shouldn't be too unreasonable for them to answer.
Yeah. Yeah.
So what does it mean if something is the midpoint?
That's
I
the
is the midpoint of CM. What does that really mean?
it's the middle of the line.
Okay, and what do you know about each part of the line?
Um, that they cross through or they're
Okay, so I always like the subway 12-inch foot long example. If you and your friend get a 12-inch foot long, they cut it in half for you. What do you know about each piece?
they're both 6 inches.
They're the same. They're the same.
Mm, Yeah,
Right. They are both 6 inches, but they're the same. So what do you know about CI, C to I, and I to M now?
they're the same.
They're the same. So they're congruent.
Yeah.
So you can say that CI is congruent to IM. This statement leads to this right here.
Okay.
Whereas in the previous proof, it was just sort of like we went and figured it out. Here, like one statement leads to the next.
Yeah. And then could you use vertical angles in this to figure
We,
out?
we will be, yeah, we will
Okay.
absolutely be using that. But before we do that, like why? What's the reason that these are congruent? And you just said it. What was the reason?
Because it's the midpoint of it.
Yeah, so you say definition of midpoint.
Okay.
And some teachers are really, strict or specific. They want you to spell everything out. Check with them, see what they want.
Okay.
All right, now let's go to the other given. I is the midpoint of BL. I is the midpoint of BL.
Okay.
What does that mean? Or that is given, but what does that tell you? It's just
Um,
like number two.
Same thing. Yeah. Like it's the middle of the line.
Okay, so what two segments are congruent as a result of that?
B to L and C to M.
No. I is the midpoint of BL. BL is this one.
Yeah.
So I is right in the middle. Cut your, Chipotle burrito in half. Each half is,
The same length or
you seem uncertain, like you don't believe me or you don't believe yourself. Like if it's the middle, then these are the same.
yeah. Yeah.
Cut a 2 by 4 in half. I don't, whatever your analogy you want to make here, those are now the same. So
Yeah.
what are those segments? Give me those segments,
Like the
like we
I'm
did
gonna
in two
lost.
here.
Oh,
Like we did in two here.
L to I is congruent to I to B.
Good. Now we need a reason for that.
Definition of midpoint.
Yes.
Uh,
Okay. Our ultimate goal is to prove the triangles are congruent. I like to make the list every time to kind of know the direction I'm heading in. You've shown that two sides are congruent.
yeah.
So you're probably not using those bottom two. So
Mm.
you either need to know that CL is congruent to BM, and it's not by looking at it,
Yeah,
or you need an angle between the two sides that's congruent. And you kind of already alluded to that.
yeah, that there is an angle.
So why is angle 1 congruent to angle 2?
Because they're vertical angles.
Exactly.
To be side angle side.
Yep. Good. So that's side angle side. Now, before we go to that though, you got to tell me what triangles are congruent. That's what we were working on last time. Like the order matters. You can't just pick like CLI and BMI. Like you have to choose the right order of the letters. Do you remember that
Okay.
from last time?
Yeah, yeah.
Could
You
you could
want
you
me
do
to
that
tell you
for
the
us
order
here?
of the letters?
Yeah, and there's a lot of possibilities that are correct, but you got to give me, the one that's correct.
CLMB.
No,
Is
no, no. The triangle. Triangle. You got to use like CL and I or CI and L or
oh
LCI like but remember it's a path. Like if you start at C and you go down to I, you're going down the single.
yeah. CIL.
Okay. It's congruent to what?
Congruent to it's congruent to MIB.
Yes. Very good. Once you've proven the triangles are congruent, you can prove anything else you want congruent. In this case, we want to show that the sides are congruent, that CL is congruent to MB. That's the CP, CTC.
Got it. Okay.
Any thoughts, questions?
No, no.
Dad, have anything, questions or?
I think this is gonna be one with a lot of muscle memory required for the test.
It is, it is. And it's hard for me to like make ones up that are like these. They're all sort of different. But if you, as the student, remember to write down the givens,
Yeah,
make some effort towards proving the triangles, you'll get most of the credit.
and everything ends in the CPLTC or whatever it was.
CP, CTC, yeah, yeah, most of the time. So,
Most of the
all
time.
right. There's always exceptions in math, unfortunately. All right, what should we do first here, Remy? What's the first thing to write? Always. Okay.
The given.
The given. We'll start with SE congruent to SU, and then go to the drawing, draw it, label it there.
Yeah,
I recommend to do it as you go. Don't wait till the end. Don't do it from the beginning. Just do it in step.
got it.
Now, this doesn't lead to anything. It's not like, oh, it's a midpoint or it's an angle bisector. It's a perpendicular. It's just, hey, these are congruent. So there's nothing to do from there. Angle MES is congruent to angle OUS. I'd like you to label in your drawing those congruent angles first. Take a shot at that and I'll do the same here.
Okay.
Let me know when you've labeled your drawing. M to E to S. Remember, it's a path. M to E to S. O to U to S.
And you want me to mark the congruency?
Yeah, I want you to label your drawing before I put it in. I want to make sure you know what that means, which angles that's referring to.
Okay.
And the hint here is that the middle letter is the vertex.
I put my angles at 1 and 2.
So that is not correct. MES is right there. M to E to S. Remember, it's a path.
Yeah.
The
Okay.
vertex is
Yeah,
the-
yeah. Yeah,
The vertex is the middle letter. The V, where they come together.
yeah.
So which is the other one?
So what's the other one?
Um,
or try labeling it in your drawing there.
Would the other one be M and O?
It's OUS. The middle letter is U.
Wait. Uh, U and S then?
It's right up there, right up there.
Yeah.
You have it on a mountaintop, I don't know what you
Yeah.
can call it. But the path, O to U to S, like that's how you the middle letter is the vertex, the V of it, if you will.
Yeah.
Okay. So we really want to prove, and I guess I'll outline it in blue here. We really want to prove that this triangle is congruent to this triangle. Okay.
Yeah.
And our possibilities are SSS, SAS, ASA, AAS.
Yeah.
So far you've got a side and an angle. So that
Mm.
one's probably out, but all the other ones are in play.
Yeah.
So you can't like make something up here. You have to like, um, you have to look at the picture and see if something else is congruent and have a reason why.
Yeah. Okay.
So what do you see? Any other angles or sides that are congruent? You kind of already referenced it as well.
Oh, 1 and 2.
Why are they congruent?
Vertical angles.
Vertical angles, yeah. All right. So now you got another angle. You've got an angle, a side, an angle. The side is between the angles. Super important. Like when it's ASA or SAS, the middle letter, the middle thing has to be between the other ones. In this case, you do have side between the two angles. So the reason that they're congruent is definitely ASA, angle, side, angle. The triangle matters. Triangle order matters here. So give me the letters of the two triangles that are congruent here.
Okay. Um, Triangle EMS is congruent to triangle UOS.
That does work. Very good. So since the triangles are congruent, that's the big deal here. You can then say anything else you want about the triangles that are congruent, sides, angles, anything like that. So MS is definitely congruent to OS by CP, CTC. So kind of referring to your dad's question or thought, like you should be able to write that for sure. You should probably be able to at least write that the triangles are congruent, the givens, and that's like 60 to 75% of it, you know.
Yeah.
And then like you throw in one or two other statements, you're almost there. So I hope that gives you some confidence that, these might be doable. They're very difficult. I mean, proofs are not really traditional math. Okay, we got a short time here. Let's see if we can quickly get down as much as we can here. So FM is congruent to AR, F to
Yeah.
M, assuming there's an R there. Those are congruent. That's looking good. And then 2, angle FMR is congruent to ARM. So I'd like you to try to label those in the drawing here. Where is FMR? Where is ARM? Remember, the middle letter is the vertex.
Okay. Um, do you want me to tell you the angle of
No,
FMR?
just label it in your drawing, and then I'll do it as well.
Okay, I put both of them down.
All right, so here is FMR.
Yeah, that's what I put down.
All right, and then
Just
ARM
both
is
for
over here. Now
okay.
this is a problem where there's actually two overlapping triangles, FMR and ARM, like
Okay.
that. It's not drawn well, but okay. So these are congruent. The red angles are congruent. So again, with that list here, and I'll just tell you because we're running out of time. This is going to be a side angle side. So what is the other side that's congruent?
To
Remember that?
F and M.
Say that one more time.
Wait, what angle are you talking about? Or
Well, the red angle and the red angle are congruent, but now
yeah,
to use side angle side, we have to have the angle has to be between the sides.
yeah.
So this is kind of like that first problem we did where there's an overlapping. MR is congruent to RM by the reflexive property.
Okay.
And that gives you the triangles congruent by SAS.
Okay.
So you always want to be on the lookout for that shared overlap side like that.
Yeah.
All right, we are all out of time for today. I know it goes quick. We really rushed through those, so pick